As I mentioned earlier, energy appears in nature in several forms. We humans make energy work for us by converting it from one form to another form. Let's consider fossil fuels. How are fossil fuels converted into other forms of energy? I will illustrate that in the following simple diagram. By burning fossil fuels, roughly 90% of the chemical energy is converted into heat. Using heat engines, thermal energy can be converted into mechanical energy. Heat engines have a conversion efficiency of up to 60%. The far majority of the current cars and trucks are based on this principle. Mechanical energy can be converted into electricity using electric generators with an efficiency of 90%. This shows that in all process steps of making electricity out of fossil fuels, at least 50% of the initial available chemical energy is lost in the various conversion steps. Chemical energy can be directly converted into electricity using a fuel cell. The most common fuel used in fuel cell technology is hydrogen. Typical conversion efficiencies of fuel cells are 60%. A regenerative fuel cell operates in the reverse modus and converts electrical energy into chemical energy. Such an operation is called electrolysis, and the device operated in such mode called electrolyzer. Typical conversion efficiencies of hydrogen electrolyzers of 50–80% have been reported. Another route of making electricity is based on an alternative fuel, nuclear energy. Nuclear energy is the energy generated in nuclear fission reactions and generates heat as well. This can be converted in electricity using the just introduced heat engines and electric generators. Next, we will look at alternative energy conversions, which are not based on fuels. Hydroelectricity is one example. This potential energy of rainwater falling in mountainous areas or elevated plateaus is converted into mechanical energy using dams. Using so-called tidal pools, the potential energy stored in the tides can also be converted to mechanical energy and subsequently electricity. The kinetic energy of wind can be converted into mechanical energy using windmills. Finally, solar energy can be converted into electricity as well. If solar light is directly converted into electricity using devices based on semiconductor materials, we call it photovoltaic. Photo means light and voltaic means electricity. Typical efficiencies of most commercial modules are in the range of 15–20%. Solar light can also be converted into heat. This is what we call solar thermal energy. Examples are heating of water flowing through a black absorber material that is heated in the sunlight. This heat can be converted into electricity again using heat engines. As the conversion efficiency of heat engines strongly depends on temperature, concentrated solar power systems are used to generate electricity through solar heating using so-called high-temperature collectors. Next to generating heat and electricity, solar energy can be converted into chemical energy as well. This is what we refer to as solar fuels. This is possible by using photovoltaics and regenerative fuel cells, but solar light can also be directly converted to fuels using photoelectrochemical devices. This means we can convert solar energy into electricity, heat, and chemical energy. In weeks 2 to 5, we discuss the photovoltaic conversion. In week 6, we will discuss the solar thermal and the solar fuel route. Renewable energy sources are energy sources that are replenished by natural processes at a rate comparable or faster than its rate of consumption by humans. Consequently, hydro, wind and solar energy are renewable energy sources. Fossil fuels and nuclear energy are not renewables, as their fuels are consumed faster than they are generated in nature. From all the energy sources based on chemical, thermal, nuclear, hydro, wind, solar and geothermal, roughly a third is being used to generate electricity. Electricity is a form of energy that can be easily and cheaply transported with relatively small losses through an electric grid. We might not realize it anymore, but electricity has made today's modern society possible. It is a symbol of modern life and progress. Electricity has been practically used for more than 100 years now. Electricity provides us the energy to cook food, to wash, to do the laundry, illuminate the houses and streets, watch TV, air condition and heat, work on a computer and surf on the internet. The access to electricity determines the living standard of humans. We must realize that around 1.2 billion out of the 7 billion people worldwide still do not have access to the electricity grid. The electricity worldwide is mainly generated from oil, coal, gas, nuclear and hydropower. Here we see the relative contributions of these sources to the global electricity generation in 2007. 65% of the electricity is coming from fossil fuels, where coal is the dominant contributor. Unfortunately, coal produces roughly 2 times more carbon dioxide per generated unit of energy in reference to gas. Nuclear is responsible for 16% of the world's electricity generation, and hydropower is with 90% by far the largest contributor among the renewable energy sources. In the conversion from chemical and nuclear energy to electricity, 2/3 of the energy is lost. 1/3 ends up in the form of electricity. 40% of the electric energy is used for residential purposes and 47% is used by industry. 13% is lost in transmission. As you can see, in 2007, transport did not play a significant role in the electricity consumption. However, it is expected that transport-related electricity consumption will increase in the coming decades as well. In 2007, 20,200 terawatt-hours of electricity was generated worldwide. If you consider a 0.5 gigawatt nuclear power plant, it means that we need around 5,000 nuclear plants around the world if our electricity needs would be fully covered by nuclear power. Realize that sources for electricity generation might differ from country to country. For example, in the Netherlands, electricity generation heavily depends on the local gas resources, whereas in Brazil, hydroelectricity is the most important resource. In the last 100 years, humankind's energy infrastructure heavily relied on fossil fuels. We are quickly using the solar energy of millions and millions of years, converted into chemical energy by the photosynthetic process and stored in the form of gas, coal and oil. How did we do that before the Industrial Revolution? The main source of energy back then was wood and biomass, which is a secondary form of solar energy. The energy source was replenished in the same characteristic time as the energy being consumed. In the pre-industrial era, humankind was basically living on a secondary form of solar energy. I'm not claiming that this energy consumption was a fully sustainable way of living. We have to take in mind that deforestation due to increasing population density was already playing a role at the end of the first millennium in Europe. The sun has been the energy source for all the processes on the surface of our planet. Wind is a result of temperature difference in the atmosphere induced by solar irradiation. Waves are generated by the wind. Clouds and rain are initially formed by the evaporation of water due to sunlight. As the sun is the only real energy source we have, we need to move back again to an era in which we start to utilize the sun to satisfy our energy needs. In this course, I will introduce you to that technology.